Ever wanted to take your PowerApps to the next level with custom charts? In this video, we are bringing together PowerApps component framework, Chart.js, and PowerFX to create powerful, dynamic visuals inside a Canvas app. You will see how to build fully customizable charts, connect them to data, and use PowerFX to manipulate everything seamlessly. Let's get started. First of all, I need to make sure that PCF can be imported to my environment and use it on my Canvas apps on that environment. When I go to my environments on Admin Center, then go to targeted environment and click on these three dots, then settings, then I go to product, and under products, I will find features. When I click on features and scroll down, I will find this Power Apps component framework for Canvas app. I should enable it, switch this on, then save. By doing that, I make sure that I can use PCF on my Canvas apps on my environment. Now on local machine, I need some requirements to meet. The first is Power Platform CLI pack, then Node.js, this is JavaScript runtime, then .NET SDK to build solution, and Visual Studio Code. Let me initialize our PCF by typing back PCF init --namespace ml chart. This is namespace. Each namespace can have many PCF projects. So let me now add the name --name chart PCF, then --template. This time we will pick field template, --run --npm install, and then hit enter. And with this, our PCF will be initialized and all npm packages will be installed. Now let me clean this up and open Visual Studio Code. With the code space dot, I can open my Visual Studio Code. Let me bring it here before you so you can see what I'm seeing now. I will go through this one by one so you can understand why and where we can start our development. After your PCF component gets initialized, you will find some folders and files. This node modules is folder that contains all the packages generated after npm install, and the second folder is your component folders that contains generated folder and two other files. First one is XML file, which is control manifest.input.xml, and a TypeScript file index.ts. Let us explain one by one. Let us start with control manifest.input.xml. This is the most important file that defines properties, events, and behavior of your component. Actually, it is the backbone of your PCF control. It tells PowerApps what this control does, what properties it has, and what external resources it uses. Now let us break it down. At the very top, we define our control. Namespace. It groups related components together. Think of it like a folder structure, okay? Constructor. This is the JavaScript and TypeScript class that will handle our logic. Then version of the PCF control. It helps us with updates. Display name and description. What user will see inside PowerApps when they add the component, just as you can see in the picture. Control type. It's standard PCF control, meaning it does not require special permissions. And then we have external service usage enabled false. This means our PCF does not depend on external services like APIs. If we were fetching data from a third-party API, we'd set enable to true and list the domains. Now, the property. This is where we define what the user can configure inside PowerApps. Let's go through them one by one. Chart type, the purpose the user selects what type of chart they want. Type text input, single line dot text. Usage input. This means that user must manually enter value, and required to be set to true means the component must have this value set. Display name key and description key. This is what you can see on PowerApps, just as in the picture. Chart data. This property is to let user to enter the data points for the chart. Chart labels. This property is to allow labels for each data point. And chart title, of course, to add a title to the chart. Chart colors. This is to allow users to customize the color for their charts. Now, you might be wondering, why are all our properties defined as single line dot text when some of them represent lists like chart data, chart labels, and chart colors? Well, the reason is there is no reason. I just want to use text input for these properties. But in our TypeScript logic, index.js will convert these comma-separated strings into arrays using dot split by comma. Okay, this way we can process them correctly inside our chart component. We will see that in minutes. Now let's talk about manifest types.d.ts. It defines the structure of the properties we use in our PCF component. Since all our properties in the manifest are of type single line.text, we define them as components framework.property types string property inside the input interface. This ensures that PowerApps correctly recognizes them as text inputs. For outputs interface, we list only the properties that the components might return. In this case, we include chart data, chart labels, chart title, and chart colors as optional with this exclamation point, meaning they might be updated and sent back to PowerApps. This step keeps our PCF strongly typed and aligned with the manifest, reducing errors and improving maintainability. Now let's take a look at the index.js file. This is the entry point of our PCF control. It tells PowerApps which class to use as the main component. I will go through the code and add more code. But let me first open a new terminal. Let me also present to you this Chart.js. This library is one of the best libraries that provide a chart. You can later go through their website and see what they have, all the kind of charts available, and also the custom chart you can build. But now let us integrate it to our PCF using npm by typing just npm install chart.js. Once this is done, we are going to import it to our index.js and start our development. As this done, let's get started. I'm going to import the chart.js to index.js. Inputs and outputs define our PCF controls, input and output parameters, ensuring type safety. Chart from chart.js/auto loads the Chart.js library for creating dynamic charts. With auto handling module imports automatically. Using the Copilot plugin, don't miss this, in Visual Studio Code makes typing easier by protecting code. Now let me create the variables where I will store the key elements of the PCF control. Container will hold the main HTML div. Chart canvas is the canvas where the chart is drawn, and context manages PowerApps parameters. Chart instance keeps track of the chart and starts as null to avoid errors before initialization. Similarly, previous chart config stores chart settings and is also null initially to allow checks before comparison, ensuring smooth updates. Init method is responsible for initializing the component. It stores the provided context and container. It creates a new canvas tag element for rendering the chart and appends it to the container. Finally, it calls render charts function to generate the initial chart visualization. The render method is responsible for creating and displaying the chart using Chart.js. How it works: if a chart instance already exists, it's destroyed to prevent overlapping charts. If the user does not provide values, default values, bar chart, months as labels, sample data, etc. are going to be used. Retrieves chart properties. For now, just bear with me for now regarding the underlying that VS Code does. I'm first writing all the retrieved properties like chart data before defining the parse number array and parse string array methods. Once all the properties are in place, I will define the parsing methods below. All the errors will go away. Parse number array takes a string of comma-separated numbers and converts it into an array of numbers. If the provided value is null, it falls back to a default value. It first splits the string by comma, then maps each part to a float using parseFloat function, ensuring the values are correctly converted to numbers. ParseStringArray method converts comma-separated string into an array of trimmed strings. If value is null, it falls back to default value. It splits the string by comma and then applies .trim method to remove any extra space around each item, ensuring clean and properly formatted string values. Now we see that Visual Studio Code is still throwing for context parameters some underlying. And the issue is that I haven't explicitly stated yet that the value parameter can be either a string or null. Once I update its type to indicate that it can hold both a string and null, the error will go away. Next, I'm going to store the current chart properties inside this previous chart configure. This is important because later when we update the chart, we'll compare the new configuration with the previous one to determine if anything has changed. If there is no difference, we avoid unnecessary rerunning. Then I initialize a new chart instance using Chart.js, passing in the chart canvas elements. The type of chart is set dynamically based on user inputs or default values. The data consists of labels, x-axis values, and a dataset containing numerical values for the y-axis. I also define background color for the bars, line by slice, along with styling options like border width and border radius for a cleaner look. In the options, I make the chart responsive and ensure the legend is displayed. Also set the title dynamically, specifying a font size of 8 to keep it readable. This setup ensures flexibility whether the user provides custom values or not. The chart will always render with meaningful data. All right, now we are going to update view. Update view method is triggered whenever the control receives updated data. This could be due to user input, dataset changes, or resizing events. The first thing we do is update this .context with the latest context parameter so that we are always working with fresh data. We extract the latest values from these context parameters and store them inside new chart config. This includes type, labels, data, title, colors. We convert both the new and previous chart configurations to JSON strings and compare them. This helps us determine whether any properties have changed. If something has changed, we completely remove the old chart canvas, create a new one, append it to the container, and call random chart to redraw the chart from scratch. If nothing has changed, instead of recreating the chart, we simply update the dataset's labels and values, then call this chart instance update method to refresh the chart efficiently. This approach ensures that we don't unnecessarily recreate the chart unless absolutely needed, improving performance and user experience. Get outputs. This method is part of the PowerApps component framework. It's used to return the output values of the components, which PowerApps can use to update other components or data sources. In this case, the chart component is display only and does not need to send any data back to PowerApps. If we were building an interactive component, for example, clicking on a chart updates a field, we would return relevant data here. Destroy method. This method is called when the control is removed from the DOM. It allows us to clean up resources and prevent memory leaks. If the chart instance exists, we call chart instance destroy to properly remove it. This ensures that when the control is removed, for example, navigating away or deleting it, we don't leave unnecessary objects in memory. All right, let us now test our component. I'm going to clean this terminal, then I'm going to run npm start. That command will start the server on our local machine. npm start, and in few seconds the server will run on port 8181. Great, now let us bring this browser here so you can see what I'm seeing now. Let us test chart type, for example, radar, then pie, then line, then polar area, and donuts. Perfect. Now what we are going to do is to build the component and initiate a solution, reference the component to the solution, build the solution, and push the solution to Dataverse. So let us do that. First of all, we need to create a solutions folder, mkdir solutions, then hit enter. Then we are going to navigate to that solutions folder, and here inside it we are going to initiate the solution. So back solution init dash dash publisher name dash name ml this is publisher name, then dash dash publisher prefix dash prefix mlt, and this is the publisher prefix. Once this done, I'm going to reference the component to this solution. So to do that, we are going to use back solution, add reference, and dash dash path, the path to the project of the component. So to get that path, I'm going to copy component path, then copy path, then paste it here. And I need to go where the project file for the component is. It is under PCF underscore charts. So I need to just delete the last. Now I can hit enter, and by doing that, we have referenced the component to this solution. Once this referenced, we can go ahead and build the solution by .NET build. This command will build the entire solution. Okay, and once this build, now we can go ahead and publish it. But before that, we should navigate to the folder where the project file is. Before we publishing, you can verify if you are set on the right environment in Dataverse. I am already on the right environment in Dataverse, and here, if you are not, you can connect to your or switch to that right environment by just typing back of create dash dash URL and the URL of your environment on Dataverse. As I am on the right environment, I'm going to push the solution. So to push the solution, you just type back PCF push dash dash publisher dash prefix, and then mlt, and hit enter. This gonna make, with this, the solution will be published to Dataverse to the right environment. By doing that, we have just published the component to our Dataverse. We are now going to build the Canvas app and use the component inside that Canvas app. Now on PowerApps Studio, I'm going to create a Canvas app. I will call it account annual revenues app. Then here I need another screen. I will add sidebar screen that groups some containers. I will delete the old one. Then inside my new screen, I'm going to add two containers, one vertical one, and the second should be horizontal container. I will reorder this to be on top of the other and set its flexible height to off, then set its height to 60. I need another container, the other kind of container inside our top container, this kind of container, because this kind of containers allows me to add a stack of controllers. In our case, I need a text label, then on top of it, I need a button. That is why I need these kind of containers. I will duplicate it inside same container, then I will add a text label, adjust it inside the container, Then I will add a button, and I need the new modern button. To enable that, you go to settings, then you go to modern controls and themes and switch this on. Now I'm going to add the new button just as inside the container. I'm going to its type and set it to transparent. Go to its text and remove this one. And now I'm going to text label and then set its text to count and the Unicode icon. Now I'm going to its color background and set it to this one. Now I need the same thing I've just developed, so I will delete the old container and duplicate the one I have developed. So the only thing I should do, go to text label and change its text to revenues and Unicode. Now for the second container on the sidebar, I'm going to add a vertical gallery. This vertical gallery has its data source as accounts table on Dataverse. I'm going to adjust this vertical gallery so it seems like two columns. The first column will be account name and the second column will be annual revenue. And because I don't want the empty rows, I'm going to filter account table to find only the rows where annual revenue is not empty. In both sidebar containers, I'm going to add some left padding to the text controllers inside these containers. With this some left padding, the UI of gallery will look better. Now on select property for this vertical gallery, I'm going to set a variable to the first account that meets certain conditions. It first filters the accounts table to exclude any records where annual revenue is blank. Then from this filtered list, it further narrows the result to find the account where the account field matches this item account, the selected item in the gallery. Finally, it selects the first matching record and stores it in account record. Now this font weight behavior for selected items should change and be only for the item or record that is stored or will be stored in account record variable. For that, I'm going to buttons and on their select property, I'm going to reset account record and set it to blank. Now when I click on one of the button, the selected item, its font weight should reset to normal. Also, I'm going to text control, and if you can see, therefore weight if it is selected, semi-bold if not normal. I'm going to change that. If not, it is selected, but if it's account equal to count record account. I need to do the same with the other text control in my items. So instead of is selected on its font weight property, I'm going to add this item if this item dot count equal to account record dot account. Then font weight will be semi-bold, if not, it will be normal. Now if I test it and select one of the items, then click on one of the buttons, it's gonna be reset. I need to hide this bar. I'm going to the bar, then to its visible property and apply the same logic. So on its visible property, instead of if it is selected, I'm going to add a condition if this item account equal to account record dot account. Only on this condition it's gonna be visible. Now I'm going to the other container on my screen and add horizontal containers on top of each other. I'm going to insert, then I type just container, and I will find horizontal container and insert the first one. And I'm going to do the same process to find the other horizontal container and add it. For the top one, I'm going to insert my component, and this is the main point of the video. As you can see, I cannot find component among insert options. So for that, I'm going to edit from preview. I will click on components tab and import a component. I will go to code tab also and refresh if I don't find my component. And my component just here. I will select it, then I import it. Once it is imported, I'm going now to insert. Only now I can find components. I will select my component and insert it in the container. I will adjust its width and set it to flexible. I will go and duplicate it in the same container so I can have two components. I will go to the other container and also paste the same component. I'm going to its container and go to its align in container property and set it to center. Now I will pick a chart type for each. I'm going to the first one. I'm going to choose chart type property and write radar. Then I'm going to the second and write do not. For the third, I'm also going to its chart type and write polar area. These charts still need chart data, chart labels, and chart titles. I'm going to the first one and pick its chart data and provide data for this property. To do that, I'm going to write this formula. It's if it is able. This formula checks if account record is blank. If it is blank, it filters the counts table to exclude record where annual revenue is blank. Then concatenate the values of annual revenue from the filtered records into a single string. As you know, we have developed the components to accept only string. Then it's going to separate them with comma. If counts record is not blank, it simply returns the annual revenue value of the selected account record. I'm going to apply the same logic with chart labels, but this time instead of extracting revenue values, I will extract full account names. If account record is blank, I will filter the accounts table to exclude records where annual revenue is blank. Then I will concatenate all account names values into a single string, separated by comma. However, if account record is not blank, I will return only the account name of the selected account. If I go ahead and test the app, I will find that the chart labels are too long. To adjust that, I need to go back and modify the formula by adding the left function. This will ensure that instead of displaying the full account names, only the first few characters are shown, in this case 6 characters, making the labels more concise and readable. For its title, let me give it counts annual revenue. And for the sake of time, I will repeat the same process on the other chart on my screen. And here we go. Let me now add the title on the top of screen for the nav bar. I need to switch its auto height to on and switch its flexible width to on. I need also to set its align in container to center, then its align property to center. Okay. And with that, our title is centered. We need to make its font size to 24 and set it to bold. Its font to bold. And here we go. Our title. We need just now to go to its text property and write accounts annual revenues. And to make the screen look better, I need to remove all the container's shadows. I'm going to the first container and set its drop shadow to none. Same thing with the second container. And here we go. If I test the app now, I can see that it looks better. But we need to justify the third component in its container. I'm going to its container and set its justify content to center. For the component, I need to switch off its flexible width, and here we go. Everything is centered. If I test the app now, I can see I can see that we have a very beautiful app. If I go ahead and select any item of the vertical gallery and then reset it by clicking on columns header, it's gonna be reset. Also, all the charts are interactive. If I hover of any area, I will get the information needed. It's very good application. So if you liked the video, don't miss the next one. Thank you so much.